Well, it looks like today, well, this video was for Wednesday, February 19th, and right now it's Monday. So I'm looking ahead, some of this may overlap. I took some lights out, so hopefully the lighting's better on this screen than it was. So you have this mnemonic. Later, when we get into gases, we'll use volume of A to moles of A to moles of B to volume of B. But right now, in the laboratory, if you were using a balance, you could measure the mass of a reactant or product. Use a periodic table to change that to moles. Use the balanced chemical equation to change that to the moles of the other one that you want. And then use the periodic table to change that other reactant or product back to mass of B. So you can say, okay, if I've got this many grams of something, how many grams of the other one am I going to need or am I going to produce? So we're going to start on problem 15 because it's the whole thing, this whole calculation, as you would see in a lab using a balance. Some of the problems, if you go back to 11, 12, 13, and 14, you're going moles to moles, or moles to mass of B, or mass of A to moles of B. You're not doing the whole thing. But in a laboratory setting, you're going to do the whole thing because grams measuring is what we have the balance for. You don't have a mole meter or anything like that. So number 15, page 377. And on Tuesday, we'll probably go through all the remainder of this stuff. And maybe you're even doing this one on Tuesday. That's fine. So this should be video Chemistry35ABlake. 15. One of the reactions used to inflate automobile airbags involves sodium azide, NaN3. And the reaction is 2 NaN3s to 2 NAs and 3 N2s. Determine the mass of N2 produced from the decomposition of NaN3 shown it right. You should be on page 377 looking along on this. So I have circled in green highlighter that we are doing the whole thing. So you should have this mnemonic written down. You should be using it. And it's good to circle what part you're doing so you know how to set this up. So the numerators in your stoichiometric equation are this, 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 and this. So what's playing what role? Well, NaN3 is playing the role of A, and N2, I think, is playing the role of B. So that's the NaN3, NaN3, N2, and N2. And I always write these the same way. I write my skeleton equation, and then it's balanced. I always use red for the coefficients in front. And then over top, I write what I have and what I'm looking for in blue. And this is what we're looking for. Okay, so we are looking for X grams N2. You always start with what you're looking for, and you put what you are starting with over 1. And then we go grams A to moles A to moles B to mass B. Okay, so there's grams A, you're going to go moles NaN3. And on the top here, you're going to go moles N2. And on top here, you're going to go grams N2. So these tell you your numerators. You should have this in one shot. Told you, show you example, ta-da. Then the rest of it's pretty easy. This goes here, this goes here, this goes here, so everything cancels. So this is grams NaN3, this is moles NaN3, this is moles N2. Now, right now, so far, a mole of NaN3 and a mole of N2 come from the periodic table. So this is 14 plus 14 is 28. and NaN3 is a 14 and a 14 and a 14 and a 23, whatever that is. That'd be 12 plus that is 15, 4 and 2, I think is 65. We'll see on the next page. This one, moles N2 to moles NaN3, comes from the periodic table. This is 2. This is 3. And you only put the 3 and the 2 here, not here and here. This is per mole. Molar mass is per mole. Molar mass is per mole. Don't add steps that I didn't show you how to do. And you won't if you're actually following my lesson. Rather than, oh, I'll do it my own way, which is going to be wrong probably. So if you follow this format, it'll look like that. And I tend to put my molar masses in purple. And so when I multiply 100 times 3 times 28, I'm going to get some number, I don't know what it is. It's going to be a little more than 7,500. And I multiply 65 by 2, that's going to get me 130. When I divide whatever that number is by 130, you get 64.64 grams in 2. Punch it all out on the calculator. Make sure this is what you get. Don't just write this down and go on and not know how to do it, or not be real proficient in it. Okay, so that is when NaN3 is playing the role of A, and N2 is playing the role of B. You follow the mnemonic, you put things where they belong. It practically works itself if you have the discipline to follow that through. So let's back up and do number 11, 12, 13, 14 then. Okay. So on number 11, let's back up and read that. I'm on page 375. Methane and sulfur react to produce carbon disulfide, a liquid often used in the production of cellophane. Okay, so you start with a balanced chemical equation. So you would have, sulfur can sometimes be 8 atoms combined in a molecule. We haven't seen that yet. I'll show that to you later. You've just written S down up to this point, which is also possible. But methane is CH4, S8, CS2, H2S. They left blanks there for you to balance that. You should know how to balance. Okay, in the problem, they want you to balance it. C, calculate the mole CS2 when you have a mole and a half of this. And they want you to calculate the moles of this. So if you start with your mnemonic and you circle the part you're doing, this is playing the role of A, and then later, and then you start with this is playing the role of B, and then in a separate step, this is playing the role, and this is playing the role of B. Now, if you got, let's see, the one they ask you to do first is this one. If you got this one right, you could use it to find that one and also get a right answer. I would recommend, though, you start with this one, because that way if you make a mistake, you're not piling one mistake on top of another one, perhaps. Okay, so you put what you're looking for here, what you're starting with here over 1. And once you do that, you only have one more step. Moles A to moles B, this is A, this is B. So 1.5 moles S8, moles B is moles CS2. And they are in a 1:2 ratio. Remember, moles S8 goes down here, so that it cancels. I don't know, like this. And they're in a 2-to-1 ratio, so that's going to end up being 3. Now, you might look at that and know what that's going to be just by intuitively seeing it. That's a good thing, but you still need to know this process because sometimes there's just too many steps to do it in your head. Okay, so if we are looking for H2S over here, question mark, and we know this is a mole and a half S8, and this is A, and this is B, we'll put S8 in the denominator so it cancels. So there's moles A, there's moles B, this goes here. 1.5 times 4 is 6 moles of H2S. Okay, then number 12. We'll start another video for it.